Hello, this is Duncan Foley and from Engineering Academy, and this is a two-part series on flowcharts. This is part A, where we're going to look at examples of flowcharts. What are flowcharts? What are the standard symbols within flowcharts? And see one or two examples. The next presentation will be part B, which will be looking at one or two examples that we've asked you to have a look at and have a go, and then we'll look at the answers or one possible set of solutions. So I hope you'll find that quite useful. If you don't know what a flowchart is, there's an example to the right here. So this is a very quick one where we've got you've got a lamp in the house, it doesn't work. So information, we've got a choice here. Lamp plug in. Is the lamp plugged in? No, it isn't. Then plug it in. Is a lamp burnt out? If it is, then replace the bulb, or you're going to have to send it for repair. So that's a basic example of what a flowchart would look like. So they're sometimes called process flowcharts, process flow diagrams and stuff. They tend to either start from the top, flowing downwards, or from the left to the right. It's sort of a picture view of a set of steps in a sequential order. It can be used for a wide variety of things. I particularly use it when I'm doing manufacturing, when I'm doing classes on robotics, when I'm asking people to break down the assembly process. What sensors will they need? What decisions will they have to make? Is there a part there? Yes or no? What needs to be done if it isn't? Or in discrete event simulations, so like flexing models, there might be a case when we have to make a decision. Is a box a red box? Therefore, it goes to a conveyor. For red boxes, it's a blue box. It goes to a blue box conveyor. It can also be used in administrative environments and the like. So when would you use them to develop understanding how a process is done? So you've got a problem down on the factory floor, you've been asked to investigate something, so you need to go and learn what's happening. So you go down, you break it down, and you're trying to understand how the process currently works, or you have to communicate how a process is being done to somebody else. Or you have to better communicate is needed between people involved in the same process. So it might be that you're leading a project and you need things to be done in a certain way, need decisions to be made in a certain hierarchical structure, then a flowchart might be useful to you. There are lots of symbols. We're just going to look at these basic 6 symbols. You can go and Google all of them and knock yourself out on that. I tend to get away with these 6 for most of the things I need to do. So a flowchart tends to start at the start process symbol and ends in a similar symbol. So we either write start or end or a brief description of what's happening in there. This is the shape you'll be using. Next is a process, so something's happening. You open the vacuum valve, you're doing something on a processor in FlexSim, or something's being assembled and stuff like that. Or another example would be add 2 cups of flour, or pick up an item, reject the item as it scraps. So you know it's scrapped, so you need to reject it and move on. So it's simply when a process is being done. When some information is coming in or some information is going out, we have an input-output for external data. So power is on, error indirect on. So you can, these symbols are quite easy to understand, but I find them a lot easier to understand when you've got an example. So we'll look at one of them in a minute. So we've got a start. We've got some data coming in, which is read data A. Then we've got to read data B. So we've got this inputs coming in, calculate the sum of A and B, then print. So it's a process. You're setting a printer off to print the sum of A and B. So it's going from top to bottom at the start and the end. The arrows are representing the flow of information or the processes and stuff. So that's quite an easy one to understand. So look at another symbol. This is a decision symbol. So the example here is in your house, and you've got the temperature. Is the temperature below 23 degrees C? So you've set that on the thermometer, and you're sort of saying, yes, it is below, therefore turn on the heater. Or no, it's absolutely fine, leave it alone. So you've got this decision. You know, it could be for a robotics, it might be, is there a part there? Yes, then pick it up. No, make the conveyor switch on and send the next part down. Arrows are as you think they would be. They're a direction of where information or process is going. See the example here we've got is a very linear one going from left to right. Start the process, add item to a shopping cart, check out shopping cart, and settle payment, and so it's literally very basic, you know, how information or process parts are going through a system. I don't use this too often, but this is a display symbol. So if you need to display something, I guess I do use it when I'm doing robotics and I want to display something to the pendant to say that, you know, is there a product there? No. So if the answer is no, I need to print something to the display symbol, or almost switch a red light on to say, you know, I've run out of parts. And if there is one there, yes, display, you know, you might want to say, yeah, we're all okay, or switch the green light on, everything's good, and let's carry on. So it's kind of useful, kind of nice to display things. What tools are available? What software available? There's loads of software out there. Some you pay for, some you don't. I don't do really big flowcharts, so I'm more than happy to use the features that come with PowerPoint. You know, you just go to the shapes. Further down, you get the flowcharts, and these shapes are more than good enough for me. So yeah, check out all of these or more. Like I say, I just use the PowerPoint. Um, how do you start when you're thinking about doing a flowchart? Don't think you can remember how a process works staying in your office upstairs. Get off your chair, go downstairs, stand next to the process, follow a part going through the production line, if you're fortunate to have the current situation there. So learn how it's done. So do the Gemba walk. So it means go to the workplace, observe, even take a camera, film everything that's happening, but make sure that everybody's working on the shop floor appreciates what you're doing. Explain to them that you're there to, you know, learn how they do things, and listen to them and make possible improvements where appropriate, or simply learn from good practice and develop another production line of a similar quality. There's loads of websites out there on things like Gemba Walks. There is another website which I would strongly recommend if you're going to get into all that sort of stuff, and lean and agile engineering, Kaizen and that sort of stuff. It's Gemba Academy. Nothing to do with us, but I do think their material is absolutely outstanding. So look up Gemba Academy if you're looking at lean and agile engineering. If you're going to do your flowcharts in PowerPoint, go to the Microsoft website. It's very good. It's possibly does more than it does more than I need. I watched the videos, but because I'm only doing quite small ones, I didn't need all of that information. I thought it was really good though, so have a look at them. I think you're best learning by doing so. Here's a couple of things you might want to have a try at. Get a piece of paper, and have a go out to 1, 2 or all of these before you look at the next presentation. So imagine going to the doctors, and what do you think the processes and decisions being made to ensure you get to the appropriate treatment? So have a think, you go through the door, who's making the decisions? You go to a counter or you go to a nurse. They want to make sure that there's a doctor available. And have a think, how do you think, or what do you think a flowchart would look like for that sort of scenario? Or a slightly easier one might be, you've got a child, you're giving them some rules about where they need to be. If it's before 4 o'clock in the day, they need to be at school. Yeah, between 4 and 7 p.m. They can be in the playground. After 7 p.m. they better be at home, having the tea and sort of getting ready for bed. So you need to put one or two little, check the time at those appropriate times, 4 and 7 o'clock, and make a little flow chart on what you think that sort of process would look like. Another one is you're sort of trying to create a flow chart for going to a fast food restaurant. You know that your daughter's going to order a burger. That's a done deal. But is she going to have fries today? Is she going to have a drink today? And don't forget to pay the cashier at the end. So a little nice, easy flow chart for that. For all of these flow charts, there might be different variants. I've done them one way. You might have done them slightly differently. So don't worry about that. Would be absolutely great, guys, if you haven't already done so, to subscribe to the Engineering Academy website. If you've got any questions about what you've seen today or any of the other videos we've got up, just email us at Engineering Academy Learning, and I'll try my best to reply to you. Have you done one of our tutorials and done something, taken them a bit further, or you've done something completely new but based on what we've done, and you'd like to share it with the rest of the group? Email us and I can arrange for a recording of your example, get you to talk about it, and we can upload it to the YouTube channel. That'd be great. Or is there a topic you think we should be covering in these new lecture programs? Just email us. Or is there a topic you'd like to discuss? I don't mind if it's got a little bit of company-based stuff in there. Don't want it to be too much of an advert, but it'd be great to see what you guys are doing. And hopefully that's been useful. Have a go at those little 3 or 4 little scenarios I've given you, and then move on to part B. Okay, thanks a lot.